construct a support vector machine binary classifier. So in this video we'll see how to create a binary classifier using support vector machine, and we will use Python for constructing the model. We will use the package sklearn, and we will include the support vector machine from that package. Let's get started and see the dataset. The dataset that we will use is the same dataset, the Indians diabetes package, or sorry, dataset that we have seen before, and we will use it in here for creating the binary classifier. We have around eight features in here, and we have one class labels, and the labels in here are either 1 or 0. 1 will be for testing positive or positive examples, and 0 will be for negative examples. I already downloaded the dataset, and I will include it and upload it with this example. From Python sklearn, we will be importing SVM, support vector machine, and we will be importing train test split to divide our data into test and training splits. We will import matplotlib for creating a plot. We will import numpy, pandas, and seaborn. Seaborn will be for creating plots, pandas for manipulating data frames, and numpy for math and arrays. The dataset is already available in the current directory, so I'll go ahead and upload it and read it, in fact, from a CSV file, comma separated file, and display the contents. So as you see in here, the dataset includes 768 different examples. We have 9 columns. One of them is the label, so therefore we have 8 features. I printed in here the shape of the dataset again, just to see it and confirm what's the size, and it looks like the size is 768 examples with 9 different columns. We printed the information about the dataset, and the dataset is all integer values except 2 of them. They are floating point value or real numbers with decimal places, decimal point. We cleaned the dataset, and we wanted to inspect the dataset for any missing values. NA and is null. We do not have any missing values. We try to drop them if we have any, and then we shuffle the data randomly just to make sure the data is reorganized randomly. Then we split the data into 60, 40, 60% for training, 40% for tests and cross-validation splits. So, and this will produce, or this produced 460 examples for training and 308 for cross-validation testing. We split this 308 into 2 halves. Each half will be 154, 1 for training and 1 for cross-validation. We printed the shape, and then we tried to plot the correlations between every pair of variables. Now, we plot also, or we tried to extract some statistics about the data, and we have seen that the data is in different ranges, so we would like to normalize it or scale it. We removed the labels and saved them in separate objects or separate variables, and we scaled the data to be, we subtracted the mean and divided by the standard deviation. And this is our normalized dataset. We try to display part of the training dataset after it's normalized or rescaled, and you can see now it's in a better set of ranges. Remember that we do not scale the actual labels. Now let's construct the model. So to construct and create our support vector machine, we used SVM, which is the object that we created all the way up from, or imported from, sklearn, and then from this SVM we call the object to construct a model that's called SVC, and we provide the hyperparameters. Remember that from our lecture we have seen the parameter C, and C is the regularization parameter, you can set it to certain values and experiment and see how your model is performing and changing this C. The default value for C is 1, so we'll keep it for now as 1. Kernel. So we have multiple kernels for the support vector machine. These are the kernels that are available within the support vector machine in Python. We'll keep it as linear kernel for now, and we can change it later on if needed. And then we fit our model. So model, which is the model that we constructed in here, dot fit uh, normalized train data set, and we provided the labels. And after we provided the labels, we tried to predict some values. So you see in here, y predict equals model dot predict normed test data, and this will provide us with the labels for the testing dataset. We tried also to predict a few 10 examples, and we printed the results, and as you see it in here, the output of the support vector machine is the actual classes. It's not a probability similar to the previous methods such as neural network. Now let's see the accuracy of the model. The accuracy of our model, we run the accuracy to calculate the accuracy on all the training dataset, testing dataset, and the cross-validation. So this is on the training dataset, and we found that the accuracy on the training dataset is 80%, around 80% or 79. On the validation dataset, it was similar to the training dataset, and a little bit less on the testing dataset, which is 0.73 or 73%. Now let's extract and see how the confusion matrix looks like. So this is our confusion matrix, and it looks like the true positives are high, which is what we are looking for, and we have a few false negatives in the corner in here. So this is all about training a support vector machine as a binary classifier. Thank you.